Reflections. A reflection is a transformation that flips a figure. So the three reflections that we will be looking at is a reflection across the x-axis, across the y-axis, and across the line y equals x. The function for a reflection across the x-axis is xy to x negative y. So all we have to do is change the sign of the y. So if you reflect across the x-axis, you change the sign of the y. When you reflect across the y-axis, you change the sign of the x. And when you reflect across the line y equals x, you simply swap x and y. Now we will look at objective 1, which is drawing the image. So here, and I'll just write my line of reflection along the top. You still see it at the top of your paper, but since mine is gone now, I'm just going to write it at the top so we know which ones we're focusing on. So here we are looking at reflecting this figure across the x-axis. I suggest that the first thing that you do be to highlight your line of reflection. We are reflecting across the x-axis, so I'm going to highlight the x-axis. The reason that I highlight is so that there's no confusion about what line I'm reflecting over. So let's take a look at the point E. How far away is E from the x-axis? It is 1 unit away. So that means that we will place it 1 unit away on the other side of the line of reflection. How far away is F? F is 1 unit as well. So we will place it 1 unit away. We will place it 1 unit away on the other side. G is 2 units. And D is 1, 2, 3, 4 units. 1, 2, 3, 4 units. All right, after you have placed all of the points, you are simply going to connect them to draw your figure. And my figure is not pretty, but you guys get the point. All right, now let's move on to the y-axis. So I'm going to go ahead and trace my y-axis. And if at all you confuse the x and the y-axis, usually your coordinate plane is labeled. So you see how there's an x here? That helps us to know that this is the x-axis. And right here we see a y. That helps us to know that this is the y-axis. So let's go ahead and reflect this triangle across the y-axis. Looking at V, V is 1, 2, 3 units away from the y-axis. So we'll place it 1, 2, 3 units away from the y-axis on the other side. W is 2 units away. And U is right on the line of reflection, so it actually does not move. It stays right there. All right, and we have reflected that figure across the y-axis. Now the next line is y equals x. So y equals x is the diagonal line. Now to be more specific, let me erase those dots. Now to be more specific, just in case you seek to understand a little further, y equals x is the same as saying y equals 1x plus 0. If we remember the linear, the slope-intercept form of a linear equation, this 0 is our y-intercept. So we will start here at 0. This 1 is our slope. Now, if we write that slope as a fraction, it would be 1 over 1. So I created this line by beginning at my y-intercept and then using my rise over run to create the next points. So we would rise 1, run 1, rise 1, run 1, rise, run, rise, run, rise, run. So you can see as I place these points, that is how I created this line. Now to go in the other direction, you would go down and left, down, left, down, left, down, left, down, left. So that is where I got y equals x, this line from. Now you will not have to do this in the future, but I do want you to understand what I mean when I say reflect across the line y equals x. So now you'll know that this is just a diagonal line. Okay? So now in order to reflect across y equals x, it's not as simple as the x-axis and the y-axis because we do have to use our coordinate pairs rules. So let's take a look at F and let's first find that ordered pair. It is -2, -2. G is -1, 3. And H is -4, 0. Now our rule for y equals x is to swap x and y. So when I have x and y swap places, this one remains -2, -2. G becomes 3, -1. And H becomes 0, -4. All right, so now all we have to do is plot these points. -2, -2, so this is F prime. 1, 2, 3, -1, this is G prime. And then 0, 1, 2, 3, 4, 0, -4 is H prime. And as you can see, we have now reflected this across the line y equals x. Objective 2, we simply have to write the image ordered pairs. So again, this is our x-axis column, our y-axis, and our y equals x. So in order to write the ordered pairs, we simply need to remember the rule. So when reflecting across the x-axis, we change the sign of the y. So I'm going to focus on each y value and change their sign. So 0, -4 would become 0, 4. 2, -2 would become 2, 2. And 5, -5 will become 5, 5. All I've done was change each of the signs of the y value. Now to reflect across the y-axis, we would change the sign of the x value. So we know that 0 doesn't have a sign, so we're simply going to just rewrite that 0 because it does not change. But this 4 is going to become a -4. So that new ordered pair is -4, 2. And lastly, we remember from above that for y equals x, we need to swap the x and y. So u prime would be 1, -4, 3, -3, 1, -1, and -3, 0. We have simply had them switch places. And lastly, for objective 3, when writing the function for reflections, it's pretty simple because as you look at the image, you can pretty much see which line it was reflected over. So hopefully as you look at this one, you can clearly see that this image was reflected over the x-axis. So all we have to do is write the function for reflection across the x-axis, and that is x -y. And as we look at this one, we can clearly see that this pre-image was reflected across the y-axis. So its function is xy -xy. And then lastly, this one can be kind of difficult to see. So the way that I do it is I ask myself, was this reflected across the x-axis? No. Was it reflected across the y-axis? No. Well, the only one left is y equals x, so it must be y equals x. So the function for y equals x is xy becomes yx. Now for these, writing the function, you can also identify the ordered pairs and notice the change between the two ordered pairs as we did with reflections, or excuse me, as we did with rotations. But if you can visually see, then it's not necessary to do that.